Okay, so welcome to my channel. Let me introduce you to, well, I have no idea what this is. Just kidding. this, this is what I'm referring to as the Centrifuge Drive Unit. Cool name, right? So this assembly really has two functions. One, I want to rotate a centrifuge, which will be these two big gray pieces here in between the gold things. Yeah, I want to rotate those around 360 degrees continuously. But not just that, I want to be able to feed power into these and also feed power in front of them because there's going to be more ship that I'm going to build in front of the centrifuge. So there's going to be ship behind the centrifuge itself, and then some ship components in front of it. So this design allows me to accomplish that. Well, I hope it will once it's built. And just to kind of orient you, the back of the ship, the longer part, the longer exposed part of this 8 millimeter steel rod, that's what this is. This is the back of the ship. Okay, this will be the back of the ship. And I'll actually build like a mount. I still got to design it, but I'll have a mount there that'll kind of plug into, and then I'll be able to tighten it down, lock it in place. And then this end is the will be the head end of the ship, the front of the ship. So it's kind of coming at you like this, right? And if you look here, you'll see these two pieces have holes in them. Okay, that is so that I can pass the wiring through. That's going to go to one of these gold pieces here. This gold this gold piece is a slip ring. So a slip ring allows me to go from static to a rotating uh, device. So the back half of this, it's not going to move, right? It's going to be static. It's going to stay in place. But this front part of the slip ring will actually spin, and it's going to spin with the centrifuge. And you can see I got the same thing going on the front side. So what I'm going to do is I'm going to pass power from the back of the ship. Um, from back here, I'm going to pass the power through these two little holes into the slip ring. It's going to come out of the slip ring into this cavity here. I'll branch out into the centrifuge itself because I want to light up the centrifuge. That'll be like the crew area and stuff like that. And then I'll bring power back out into this front slip ring, and again we go from rotating to static. And then I'll have the wires coming out of here. I'll feed like lights and whatnot. Maybe I'll have a little radar spinning or something. I don't know yet, but I'll be able to pass power to the front of the ship. So looking at this design, you can see I've taken care of the power issue, right? So that's the slip rings. We'll go ahead and hide those, get those out of the way so we can focus on the drive itself. So the drive is a 5 millimeter, got a little 5 millimeter steel rod drive shaft, and it's hooked to what is this, like a 20 tooth pulley. And then I got a little drive belt between, so it's just a 1-to-1 ratio from one 20 tooth pulley to another 20 tooth pulley. And this second 20 tooth pulley, or the one that's on the 8 millimeter rod, it's mounted into this flange. Okay, and this flange will then be, I don't have the screws on here shown, but it will be screwed into the back half of the centrifuge hub. And then the front half of the centrifuge hub, I got another flange here. And this one you can see a little bit better. So no pulley needed on this end, but you can see I've got an 8 millimeter ball bearing. I've also got a ball bearing on this one too, but it's kind of hidden in there. Let's get rid of this for a sec. Yeah. So you see I got it sandwiched right up next to this pulley. I got an 8 millimeter ball bearing there too. So looking at this pulley, you can see neither the flanges nor the not the pulley, sorry. Looking at the hub, you can see neither the flanges nor the hub actually make contact with the 8 millimeter rod. So if I hide this guy, you'll see, maybe you can see, I hope you can. Yeah, see, like there's this gap here. Here's the 8 millimeter rod. There's a little bit of a gap before we get to the flange. So there's the other let me turn that other one on. but you can see now they're not actually making contact, right? I wanted to do that to reduce friction. So really only 2 points are contact of the hub, of the centrifuge hub. Only 2 points are contacting the 8mm rod. And even this this pulley here that's on the, here, we're going to hide some stuff, get it out of the way just so it's less confusing because I get a lot of junk on the screen here. So this pulley here, this guy, I'm going to bore this out. So it's an 8mm, it's adapted for an 8mm rod. It's got an 8mm hole in it, but I'm going to bore it out so it spins real loosely on there, and once I orient it so it's locked into that little flange, it won't even touch the steel rod anymore. The only thing that will be touching the steel rod are the two bearings at the back and at the front, and that's it. And so that'll make things a lot, I think, a lot easier as far as friction goes. I won't have as much, the engine won't have to work, or sorry, not the engine, the DC motor won't have to work as hard. And I believe it's a 12 volt DC 10 RPM. It's like a low RPM, high torque motor. So I don't want to work it too hard. And I also, it's going to be driven by that belt. So I don't want to risk slipping the drive belt. If things are if there's just too much friction with the centrifuge. So what I'm going to do is I'm going to take it from design now, because we're looking at it right now in Onshape, which is like an online AutoCAD application for those of you who aren't aware. And I'm going to take it from here. I'm going to print out these parts. Everything that's here, it's all going to be PLA. I think that's how I'm going to do it. I'm just going to print it on my Bamboo A1 FDM printer. I'm just going to knock these out, and I'll probably film that part, and then I'll show it all being assembled, and hopefully I can get this thing working and working properly. Fingers crossed. Okay, let's proceed.